So section 3.7 is going to discuss the double angle formulas amongst some other things. And when I introduce these formulas to you for the sine sum and the cosine sum identities, so formulas like this one, and likewise down here for the cosine, I suggested if you knew these two, you could derive for yourself a lot more identities. And we can see that in this particular example right here. What I'm going to do is I'm going to replace alpha by beta. So wherever there's an alpha, I'm going to write a beta, alpha, beta, etc. But now I've got beta plus beta inside the parentheses of my my sine sum identity. What do I get when I add beta plus beta? What's beta plus beta? Don't say beta squared, please. Beta plus beta, or
Beta.
How about twice beta? Right? You add one of them plus one of them, you get two of them. So, okay. So I get sine of 2 beta equals sine of beta, cosine of beta, plus sine of beta, cosine of beta. Now you might notice that in going from the second line to the third line, I switched the order here. Now why did I do that? Well, I did that for the same reason that we've got beta and beta here. You've got like terms. So here I had one of them here plus one of them here. 1 plus 1 gave me 2. And I kind of got that same thing going on down here. I've got one of these here plus one of them here. So I end up with a formula for the sine of 2 times beta. And what would that formula be? Can anyone tell me? Start this way. What's 1 plus 1? 2.
2.
2. Thank you. So it's 2 of these, right? 2 of sine beta, cosine beta. And what this is saying is if I know the sine of an angle and the cosine of an angle, I could also find sine of twice that angle. So if I know what the sine of, say, 30 is and the cosine of 30, then I can get the sine of 2 times 30, or 60. Now, it actually has more uses than just that, but that's what's going on here. This is the double angle formula. Let's repeat that down here. Cosine of alpha plus beta. All right. The unfortunate thing about your cosine sum formula is that the sum here goes with the difference here. They're not in nice concordance like they are up here. Yeah, oh well. But we're going to play the same game here. I'm going to replace alpha by beta. I get cosine alpha cosine beta replaces cosine alpha, and then sine beta replaces sine alpha. But can anyone simplify this? What's another way I could write cosine of beta times cosine of beta?
Cosine beta squared?
Yeah, but we've got to be careful. That squared is going to go right here.
Okay.
Yeah, the beta is not squared, it's the cosine that's squared. So thank you. And likewise, this is sine squared of beta. Now, here's where it gets a little bit interesting. There's a lot of variations of this formula. This is one of them. So far, we've derived this one and this one. But let's see if we can keep going. After all, one of the things you should know is the Pythagorean Theorem, and that is sine squared of theta plus cosine squared of theta. Theta equals what? 1. That means that cosine squared of theta equals 1 minus sine squared of theta, or sine squared of theta equals 1 minus cosine squared of theta. And with those formulas, I've got a couple more substitutions. I can replace cosine squared of theta with 1 minus sine squared of theta. And if I did that and cleaned it up, I would get 1 minus 2 sine squared, in this case beta, like that. So that would be another version of this formula. Let me actually show you the work in this particular case, the last one. So I replaced cosine squared of theta by 1 minus sine squared of theta, and I got this formula. What's something else I could do with this formula? How else could I play with it? I could replace sine squared, and let's just see what happens there. Cosine squared of theta, or excuse me, cosine squared of beta minus, I'm going to replace sine squared of beta with 1 minus cosine squared of beta. How does that simplify? Well, I could distribute the negative sign and get cosine squared of beta minus 1 plus cosine squared of beta. I'm going to write that down here. Cosine squared of beta minus 1 plus cosine squared of beta. Yes, thank you. So James here in the class, 2 cosine squared of beta minus 1. So it's important to notice that we have not 1, not 2, but 3 different versions of this formula. All 3 of them are different versions. Now, a couple of them are really handy, and they're things that I tend to test you on, and I'll explain how and why. So, here we go. I like this version of the formula, and I like this version of the formula, because if you know what the sine is, then you can calculate the cosine of 2 beta. Or if all you have is the cosine, then again, you can still calculate this. The unfortunate thing about this formula is that you need to know cosine and sine in order to find this quantity. All right.
I have a quick question. I missed for the first, the 1 minus 2 sine squared. Where did the 2 come from? The 2 sine?
All right. I
missed where that came from.
That's a fair question. I didn't actually show that, but let me go back and show you how it would be derived. So if you replace cosine squared of theta, I guess that should be a beta here. But what could I use to replace cosine squared of beta? Think up here.
The 1 minus sine?
Yeah,
Squared?
1 minus sine squared of beta. Now, let me remove the parentheses or brackets here. And notice that I've got a minus 1 of them here and a minus 1 of them here. If you combine like terms, I've got 2 of those. 1 minus 2 sine squared beta. So that's where it comes from. So now, how many of these versions do you want to derive and how many do you want to memorize? It's up to you. I mean, it's handy to memorize some of these. You know, I just hope you don't have to memorize all of them. I hope you can derive a few of them, but you know, that's up to you. Whatever works best for you is fine. You are going to need to know the sine and cosine double angle formulas. The tangent double angle formula actually follows from the tangent sum formula. We used that earlier with Kira's problem. Let's see. Let's play our same game, except I'm not going to do things out quite as detailed as I did here. But if I had tangent of beta plus tangent of beta, what do you think is a different way I could write tangent of beta plus tangent of beta? 2 tangent of beta. I have 1 of them plus 1 of them, so there we go. And down in the denominator, if I replace alpha by beta, so that I end up with a 2 tangent, or tangent of 2 beta here, I'll have tangent of alpha times tangent of alpha. What's another way to write tangent of alpha times tangent of alpha?
Tangent squared alpha.
Yep, tangent squared. Perfect. So in this case, there's your tangent double angle formula. So maybe what I should do is ask you to prove that. If I give you this, prove this. Who knows? Who knows? All right, but let's actually use these in some examples and try and get a feel for what they're all about. So let's get down to trig here. Let's start with problem number 9. So these are the nice friendlier numbers that I promised you earlier that I would work with. And let me start by delivering with some of those. So I want to find the sine of 2 alpha and the cosine of 2 alpha given that sine of alpha is 3/5. So I'll actually do these in slightly reversed order. There we go. So I'll just call this example A. That's really problem number 9. So we've got sine of alpha is 3/5. And we want to find sine of, I think I might have said alpha. Sine of 2 theta and cosine of 2 theta. And we'll start with the second of these first. And there's a good reason for that. Cosine of 2 theta has several different expressions. It could be cosine squared of theta minus sine squared of theta. It could be 1 minus 2 sine squared of theta. Or it could be 2 cosine squared of theta minus 1. One of these is easier to use than the other one. Actually, than the other two. Given what we've got, which one of these would you use? A, B, or C? Which one looks like a winner?
B.
B. Because we already know what sine of theta is. So cosine of 2 theta would be 1 minus 2 times 3/5 squared, which is 1 minus 2 times 9 over 25, which is going to be 7/25. Now, if you're not good with the fractions, don't worry. Your calculator can come to the rescue. Or decimals can come to the rescue for that matter as well. But let's take a quick look at this on your graphing calculator. So let's clear that out. So I want to calculate 1 minus 2 times, parentheses, 3 divided by 5, and hit the square key. And what I'll get is probably 0.28 maybe. And if you're looking at that and saying, well, I know my instructor prefers a fraction, no problem. Hit the math key and then press enter twice. There's your fraction. Nice. Nice. Unfortunately, we still have more to go. But we're okay with the first part of this. We're okay with the cosine of 2 theta. Let's try sine of 2 theta. And,
One quick question.
yeah.
So we were just basically replacing beta with theta for that formula?
So what we did was I replaced sine of theta with 3/5 because we were told at the beginning of the problem sine of theta was 3/5. So I took this version of the formula and replaced the sine of theta with 3/5. Okay? All right. Let's try the other part of this. So that is, let's find cosine of 2 theta. I mean sine of 2 theta. Sine of 2 theta. And it's helpful to recall what sine of 2 theta is. So sine of 2 theta is 2 sine of theta times cosine of theta. Well, there's kind of a bummer about this. And the bummer part is I don't know what the cosine of theta is. So, okay. Now in these problems, they'll tell you something like 0 is less than or equal to theta, less than pi over 2. So that tells you where to draw a triangle in association with the thing that they do give you. And that triangle is going to be drawn in the first quadrant. So, okay. So here we go. So I know that sine of theta is 3/5. Help me out. Sine is what over what? Sine.
Opposite over hypotenuse.
Yeah, opposite over hypotenuse, thank you. So that's going to be 3/5, and here's my theta. I'm hoping that you're familiar enough with a squared plus b squared equals c squared to finish solving here. If you plug in 3 squared plus b squared equals 5 squared, you'll end up with this side equaling 4. Yay. Now we went through all that just to be able to tell what the cosine of theta is. So this little triangle of dots means therefore cosine of theta, cosine of theta. What's cosine of theta going to be?
4/5.
Yeah, 4/5. Perfect. Adjacent over hypotenuse, 4/5. And so 2 times sine of theta was 3/5, times cosine of theta, which is 4/5. And if you multiply the numerators, 2 times 3 times 4 is 24 over 25. That's your denominator. And that's the sine of 2 theta. Beautiful. Yeah, worked out nice. Okay. How are we looking here? Doing all right with that first one? One of the big things I wanted to get across to you, and something that I always test on, is this. I'll give you a problem just like this, so that if you know the correct version of this formula, then it makes life a lot easier. As opposed to if we use this first one, you know, now I got to know what sine and cosine is. So, in fact, let's go back and just double check this since we've got this extra information. What would happen if I, let's see here. Let's see. Yeah, what would happen if I went up here and calculated the cosine double angle formula with this as opposed to what I did use? So let's revisit that. So cosine of 2 theta would equal cosine squared of theta minus sine squared of theta, which is 4/5 squared minus 3/5 squared, which is 16 over 25 minus 9 over 25, and guess what? End up with 7 over 25. The nice thing about that is that it matches what I got earlier. If you look back and compare our answer here, matches what I got here, 7/25. So all these formulas are always going to work. It's just that sometimes one of them is more convenient than the other. So it's nice to have all three around, and it'll pay benefits if you do. Okay. Any thoughts on this first one before I do a harder one, kind of like what the book might have? All right. I'm a fan of, giving you reasonable problems, but there are some in my math lab that are a little bit more challenging. So let's see, we'll call this example B. Sine of theta equals 2/9. 0 less than theta less than pi over 2. That's telling you that your angle is in the first quadrant. And kind of like the last one, I want to find cosine of 2 theta and sine of 2 theta. So if you're doing this one, if this is all you had to do, then there's a good choice of a formula. It'd be 1 minus 2 sine squared of theta, which is 1 minus 2 times something squared. What should I put in here? What goes in there? What am I going to square?
9.
2/9. Thank you. So 2/9. And look, there's no reason to get bogged down with fractions. Just make your calculator do it all right? It's pretty easy. So it's 1 minus 2 times parentheses 2 divided by 9, and then hit the squared key. And that looks kind of ugly, but you can clean it up. Hit the math key. Now, this clean it up stuff will work as long as you've got a nice fraction that doesn't involve square roots. If you have irrational numbers like pi or the square root of 2 or square root of 3 or square root of 2,597, it's not going to work. But for this one, it worked out great. 73 over 81. 73 over 81. Yay. But unfortunately, life's not going to be quite so nice to us there, because we need to do sine of 2 theta. And for this, I'm actually going to have to write down a triangle. Now, if you're watching this video later, you might want to pause it and try and write down your triangle and label the sides before you take a peek at what I label. Draw your triangle in the first quadrant, because that's where we were told it would be. That's theta. Ready, fire, aim. All right, so what's this side going to be? All right, it's going to be opposite over hypotenuse, so 2 over 9. This side, well, that's going to be a little bit of work. You're going to have 2 squared plus b squared equals 9 squared, or b squared equals 81 minus 4, or b equals the square root of 77. All right, it's just not a nice friendly number. Not much we can do about it. Let's just see how it works out. Sine of 2 theta. Well, for better or for worse, there's only one version of this formula, and that's this one. 2 sine of theta, cosine of theta. And if I fill things in, what's it going to look like? Well, it's going to be 2 times sine, which is 2/9. What's the cosine? Can someone fill in the cosine for me?
Square root of 77.
Square root of 77 over 9. Thank you, gentlemen.
How would it be? Oh, yeah, 'cause it's C.
So Katoa, so adjacent over hypotenuse. So square root of 77 over 9. That gives me 2 times 2 is 4. 4 square roots of 77 over 81. Yay. If you really wanted to be fancy, you could check your answer in the following sense. This squared plus this squared should give you 1. Because remember, sine squared plus cosine squared equals 1. But, all right, looking good there. Comments or thoughts on example B here? Doing all right? Can I get a thumbs up there from my home audience? All right, thank you, thank you. Let's try a different one. And notice there's one in your homework that follows along these lines, and that is, let's call this example C. Tangent of theta equals 7/8. And theta is between pi and 3 pi over 2. Pi is less than theta is less than 3 pi over 2. So first things first, what quadrant is theta in? Where should I draw this angle?
3.
Yay, winner, winner. So
Chicken dinner.
yeah, chicken dinner. Thank you. That's a thing that they say out in Vegas when you're playing craps. They'll say winner, winner, chicken dinner. It's been around since the 50s, from what I understand. In any case, let's take a look at that here, and let's start by drawing this angle. Now tangent, let's go back to SOHCAHTOA, right? SOHCAHTOA. Tangent is what over what? Opposite over adjacent. Nice. All right, so draw yourself a triangle. Now those triangles always get connected to the x-axis. Never draw one back to the y-axis from your hypotenuse. Now I'm not trying carefully to draw it to scale. Tangent would be opposite, so what's this side compared to my angle? Well, that's my theta here. That's your opposite side. So the opposite side, I'll start out with a 7 here. And then I've got 2 other sides along the x-axis and this one over here. Where am I going to put the 8?
The top.
Top, yes, thank you. So the top. Except there's something wrong here. Can anyone see what's wrong? What looks wrong about this?
The 7 needs to be negative.
7 needs to be
And the
negative.
8.
Well done. Both of them need to be negative. Let's put in those big negatives because you're in the third quadrant. You're below the x-axis and you're to the left of the y-axis. So both of those need to be negative. All right, great. Now let's see. Now we can answer any question we want. We can do sine of 2 theta. There's going to be 2 sine of theta, cosine of theta. So, all right. We haven't heard from you yet today. What's the sine of theta? Ooh, I guess there's probably one thing we're going to need before we do the sine of theta. Can anyone tell me what I need?
The hypotenuse.
Yeah, the hypotenuse. Great. So the hypotenuse is going to be
Or 105. Or should it?
I think 115 maybe. Let's see.
Yeah, I realized I messed up.
That's all right. Square root of 7 squared plus 8 squared. Actually, negative 7 squared plus negative 8 squared, but when you square the negatives, they come out, they disappear. So it'll be square root of 113, right?
Yeah, 13.
113. square root of 113. So, all right. 2 times the sine, which is going to be -7 over the square root of 113. And the cosine is going to be -8 over the square root of 113. And the product is going to be 2 times 56, which is 112, over 113. Because you get the square root of 113 times the square root of 113. Beautiful. So, not the easiest numbers all the way through, but yeah, we got there. We got there. How are we looking on that one? Doing okay? Why don't you see what you can do with the cosine of 2 theta? See what you can come up with there. And pause the video if you'd like, but give yourself a chance at that one. It's cosine of 2 theta, not 2 cosine of theta. So you might use one of those formulas. All 3 of them work. It's whatever you think you find most convenient. All right, so I've got one answer here. All right. Okay, got a couple people agreeing. All right, starting to get some answers here. That's good. So, Colleen, Sean, Crystal, Victoria, Lucas, all looking good there. And Jennifer chiming in as well. Thank you all. Now I'm curious, there's 3 different versions of this formula to use. A, B, and C. I don't think one of them is much better than the other one in this case because, you know, we've already got sine and cosine, so which one did you use? A, B, or C?
A.
A?
A.
B? All right, anyone use C? B? Couple Bs? All right, let's see. So, I guess I like this one, 2 cosine squared of theta minus 1. It really doesn't matter which one you use. You're still going to get the same correct answer. So that's going to be 2 times cosine, which would be negative 8 over the square root of 113 squared minus 1. And again, if you want to let your calculator do the work, that's great. It's going to be 2 times 64 over 113 minus 1, or 128 over 113 minus 1. But how if I write that 1 as 113 over 113? That gives me a common denominator, and I can subtract the numerators and get 15 over 113. Look, you can do all that on your calculator. That's fine. No worries there. Cool. Cool, cool, cool. All right. Hopefully you're feeling good about the double angle formulas. Comments or thoughts on that last one? Let's see here. Is there anything else I want to do? Yeah, let me do a couple more of the double angle formulas. And these are some of the harder ones towards the end of your homework. So, like for this one, I think we're up to example D. Find the sine of 2 times the sine inverse of negative 4/5. Wow. Okay. So this one's a little sneaky. Now this is one that if I put it on the test, I would do so with the agreement that you're gonna show me your work. Because you know what? Your calculator can give you an exact answer in a heartbeat. I want you to show me that you understand what this is saying and what's going on here. But maybe let's just take a look at the answer first, all right? So that we know we got the right answer when we got it. So let me clear out all this stuff here. There's nothing wrong with you checking your answers. I'm completely in favor of that. I want you to do well in this course. So sine of 2 times the inverse sine of negative 4 divided by 5. So a lot going on there if you keep up with the parentheses and stuff like that, but okay, something like that. And you get negative 0.96, and then you're like, oh, but my instructor likes fractions, so you dutifully do the answer to fraction key, and you're like that. Oh, but wait, we had it in radians, didn't we? What would have happened if we had it in degrees? Let's change our mode. Let's put it in degrees. And if I put it in degrees, and I go back and I do my previous calculation, oh, I get the same thing. So fortunately on this one, it doesn't matter if you're in radians or degrees, because one of the functions does something and the other one undoes it. As long as they're in the same units, you're okay. But how are you actually going to work this? How are you going to show me your work so that I'm a happy camper and you get 100% and we're both happy? Keep in mind something about this right here. Now, I said this back when we covered the inverse sine and cosine functions. When you take the inverse sine or cosine function of a number, what is it that you're going to get?
An angle.
An angle. Beautiful. Beautiful. Who said that?
I did.
Awesome. Thank you, Kara. So you're going to get an angle. I'll tell you what. I'll let you name this angle. Do you want to use alpha, beta, or theta? What's your choice?
Alpha.
Alpha? All right. So essentially what we've got is, this is the sine of 2 times alpha. All right. Well, what do we know about alpha? Alpha is the inverse sine of negative 4/5. That's equivalent to, what is that equivalent to? What's another way I can rewrite this? Can anyone rewrite that? Well, let me take a look here. I really don't like that inverse sign there. It's just kind of messing with me a little bit. So I've got alpha, sine inverse of -4/5. What would be the opposite of the inverse sign? What operation undoes the inverse sign, like the square root does the inverse of square? What operation is the opposite of the sine inverse?
Sine.
Yeah, the sine. So what if I took the sine on both sides? Then I would get sine of alpha. And what's that going to be on the right-hand side? Anyone tell me? What happens with these two? Sine of sine inverse, they
Oh, they cancel?
cancel. So you get -4/5. Yay. So that's what it's telling you, that the sine of this angle is -4/5. Now, you're going to have to think about the range of the inverse sine. So recall the range of sine inverse. Sine inverse is going to give you an angle between what and what?
Pi over 2 and negative pi over 2?
Perfect. Either the fourth quadrant or the first quadrant, somewhere in there. But because sine is negative, then it has to be in the fourth quadrant. So I'm going to draw an angle in that fourth quadrant. And this is what I want to see when you do these problems for me. So that's my angle alpha, but really I'm going to look at it from the point of view of this little reference angle down here. That's going to be opposite over hypotenuse, so -4/5. Are you guys getting familiar with these sides well enough? If this is -4, that's 5. What number am I going to put there? What Pythagorean triple works there?
3.
3.
3, yay. But this is what I needed. And now that I've drawn that, I can do sine of 2 alpha is 2 sine of alpha, cosine of alpha. It's drawing the triangle that's the hardest part. It's getting that. And I'll do one last example like this for us, but getting that piece is the hardest part. Sine of theta, we started out with that. That was -4/5. And then cosine of theta, or cosine of alpha, I guess I should say. Cosine of alpha is what?
3/5.
3/5. So -24/25. Awesome. Thank you, Lucas. All right. Pretty sweet. Pretty sweet. Comments on that one? Let's do one last one like this. But let me go back here. Are you okay with how we drew the triangle? Because if you can get this, then the rest of the problem's not so bad. I started out by recognizing, actually Kara recognized for us that the inverse sine or inverse cosine of some number is going to give you an angle. So we just said, you know what? This is really a sine of 2 alpha problem. And alpha is this right here. Now we turned this around. Instead of alpha is a sine inverse of -4/5, we turned it around to sine alpha equals -4/5. Those two things are saying exactly the same thing. So this here and this here. They're saying the same thing. So if you want to just go from this to this, that's fine. Once you have it like this, you can draw your triangle. Make sure that you draw it in the proper quadrant. This one was in the 4th quadrant because of the range of the inverse sine. Once we got the triangle, then it's just a matter of filling in the formula. Okay, last one. And for this one, let me start out by reminding you, or informing you of a property. So this one's going to be example E. And reminder, or maybe it's not a reminder, maybe I'm just telling you for the first time, that tangent of 2 theta is 2 times the tangent of theta over 1 minus tangent squared of theta. So we're going to need that because this one's going to be a tangent type problem. Let's do this. Let's do tangent of 2 times the cosine inverse of negative 4/5. All right, so fairly similar, at least in the way we start, to the way we did the last one. That's some angle. So that this really turns into tangent of 2 times alpha. It's a tangent double angle formula, at which point you can fill in the formula 2 tangent of alpha over 1 minus tangent squared of alpha. We just got to figure out what the tangent of alpha is. Okay, well, let's start with this right here. Alpha equals cosine inverse of negative 4/5. What's the range of the inverse cosine?
Zero to pi.
0 to pi. That means that this angle has to be somewhere in the 1st or 2nd quadrant. But because it's negative, it has to be in the 2nd quadrant. So let me draw that angle in the 2nd quadrant. Now, this, and I'm going to take the shortcut here. If you take the cosine of both sides, you get cosine of alpha equals negative 4/5. Okay. Like I said, when it comes to drawing these triangles, just draw anything. Make sure that the line goes to the x-axis, not to the y-axis ever. Adjacent over hypotenuse. Take a second and try and write this in before I write it down. How is that triangle going to be labeled? What over what? And then use the Pythagorean Theorem to finish it off. So here's our reference angle, and here we're really talking about the angle over to here. But the adjacent side is going to be negative 4. The hypotenuse is going to be 5. That puts a 3 over here. Is that 3 going to be positive or negative? Positive. Yeah, thank you, gentlemen. Because it's going to be in the 2nd quadrant. Beautiful. All right. Now that you got your triangle, now I can fill in the rest of this. What's the tangent of alpha? Tangent would be opposite over adjacent, right? So 3 over negative 4. Something's bothering me here. Oh, okay, never mind. 3 over negative 4, like that. Now again, for those of you who aren't a fan with fractions, putting this in can be kind of a pain. So let me give you a nice little workaround into dealing with that kind of thing here. So take out your calculators and kind of follow along with me. Let me clear out all this stuff here. Here, get rid of that. Here, get rid of this. The first thing I want to do is I want to store the value of negative 3/4. So take negative 3 divided by 4 and hit the store key right above the on button. And store that in X. X right up next to your alpha key here. So you can see all the buttons that I've pressed so far. And then just press enter. Now with that, now this calculation, this formula becomes pretty easy. Because I need 2 times x divided by 1 minus x squared. So this is going to be pretty easy. Let's just take care to use parentheses. So here's going to be my 2 times x divided by parentheses 1 minus x squared, and then a closed parenthesis. Bam. And then if I press the math key, I think I'll end up with 24/7 and negative 24/7. Beautiful. Worked out pretty nice. Now, if you're afraid you're going to forget these parentheses, like, oh, I know I'm going to forget those, there is another workaround for that. If you want to hit the alpha key, then the y equals key, the first option here allows you to draw a regular fraction, the way I do it on my paper. And so now I can just type in 2x and then press the down arrow, divide by 1 minus x squared. This time I didn't need to use a parentheses because of the way the fraction is drawn. Works out nice. So, is that a useful trick on the calculator? Anyone?
Yes.
Okay, cool. All right, that'll do it for section 3.6, at least as far as the double angle formulas. We're going to have to come back and finish the half angle formulas in a little bit, but this will take us up through the double angle formulas.